Welcome back, everybody. Okay, so the third piece to our piecewise functions is first we graphed, right? And then we talked about evaluating and solving. And now we need to talk about writing the equations because we need to be able to go both ways. So yes, we need to be able to graph, but we need to be able to look at a graph or look at given information and write the equation from there. Okay, so let's take a look at example number 3 for skill 3. A long distance calling plan charges 99 cents for any call up to 90 minutes. Okay, so 99 cents up to 90 minutes. And then 7 cents for each additional minute. Write a piecewise function to represent this situation. Okay, so I only see two pieces. I see this one and then I see the tag on, right? Well, let's figure this out. So if I go 0 to 20 minutes, I'm only paying 99 cents, right? But anything beyond, so we'll say 20 plus, is going to be this 99 cents plus 7 cents per minute. But something to think about. Okay, if we call 21 minutes, right? We make 21 minutes worth of calls. Do we want to pay 7 cents for 21 minutes? Absolutely not. We want to pay 99 cents for the first 20 minutes. And then we want to pay 7 cents for every minute beyond the 20 minutes. Think about that for a second. If we talk 25 minutes in length, right? We only want to pay for that 5 extra minutes. So we need to say this is how long we talked. We're going to take away the 20 minutes that's represented in the 99 cents. With piecewise functions, you usually have to account for the fact that you're taking away what you've already paid for. Okay, so you can leave it like this, or I know I've got a lot of arrows and stuff. Let me take that away. That's a lot to look at. You can distribute the 0.07. So we would have the 99 cents plus 0.07x minus 0.14. And actually, now that I think about that, let me fix that because we have an additional 0. So it's minus $1.40. That makes more sense. Okay, so then I'm going to take the 99 cents and I'm going to subtract the 140 just to keep breaking this down, and it's 0.07x minus 0.41. So that would be our equation in slope-intercept form. The reason I went all the way down to that is because it's going to be easier for us to evaluate, for people to graph if they wanted to graph, and so forth. Here we go. The first is 99 cent flat rate, and that's when your x is greater than 0, and it says up to 20 minutes, so it's an equal to, because it includes 20. And then we have 0.07x minus 0.41 when x is greater than 20. There is our equation. Nice. Again, if you need to, rewind. That's what's so nice about these video notes is if something doesn't stick right away, you are always welcome to pause, rewind, and listen to it again. Make sure you're writing down questions for me if you have them, okay? We can post them in a discussion. You can ask your classmates, and you can absolutely 100% ask me. I love questions. Okay, moving on. How much would a call lasting 23 minutes cost? Okay, so that's this guy because it is greater than 20. Oh no, my box of my answer went away. There we go. So we're going to plug it into that equation. I'm going to say, well, f of, you can even put 23, is equal to 0.07 times 23 minus 0.41. Okay, so putting it into my trusty calculator, I get that would be $1.20. That's not bad if you're not talking that much. So that would be our final answer. Okay, so that's the word problem type situation that you might come across. Make sure you're always accounting for taking or subtracting or not double paying for the original, okay? All right, here we go, ladies and gentlemen. I am going to switch colors because I can. All right, write an equation from the graph. So here I see I have 1, 2, 3 different pieces. And I'm going to write them out individually and then put them all together. It's totally up to you how you would like to do it. This is just one way, okay? So the first one, man, I see that I have a point right here. And then it looks like it goes up 2 and over 1, okay? So that means if I go up 2 and over 1, that's my slope. And then I'm going to go up 2 and over 1. Okay, so then that means that my y-intercept is 0. Oftentimes, yes, you will have to extend up or down to find where that graph is going to intersect the y-axis. And I see that it's when x is less than -1. And I say less than because of this open circle right here. Okay, the second piece is y is equal to 1 because it is a horizontal line through 1 at the y-axis. It is closed at -1, so that's less than or equal to, but less than +1. Okay, the third piece, I go up 1 and over 1. Oh, interesting. So then I'm going to go down 1 and over 1, down 1 and over 1. There's my y-intercept. So the slope is 1x. You can write the 1. You don't have to write the 1. It's mathematically accepted that if there isn't a number in front of x, it is a 1. And I'm going to have -1 as my y-intercept. Now it's closed at 2, so we're going to say that x is greater than or equal to 2. Notice this is not, let me erase all my drawings. This is not a continuous function. There are holes. It is not connected, nor, well, rewind, and it is a function because it passes our vertical line test. So the final step is we're going to write f of x. This is a function of x. We just talked about it's a function. I'm not going to rewrite y equals. Ladies and gentlemen, that is redundant. It is unnecessary. It is not mathematically accurate, okay? This is your y equals. Don't write it again. If you need to write that down on your notes and circle it, highlight it, star it, something, please do so. Okay, so f of x is equal to 2x, f of x is equal to 1, f of x is equal to x minus 1. It is equal to 2x when x is less than -1. It is equal to 1 when x is greater than or equal to -1 but less than 1. And it is equal to x minus 1 when x is greater than or equal to 2. Boom. If you are not comfortable with piecewise functions, I highly suggest numbering the pieces and going through it piece by piece like that. Ha, no pun intended. Get it? Piece by piece. Yep. I'll be here all year. And if you are comfortable, you're more than welcome to go straight to this step. I don't care what your preference. I want you to do what is easiest, what is most sensible to you, please. Okay, I know I'm going to say that a lot. All right, B, to be or not to be? That is certainly not the question we are asking at this moment in time. Okay, I see two pieces. I see the left, I see the right. I also see that they are not going on forever. Please don't assume that they are. Mrs. Dahl and I are really particular about making sure all of that information is given to you. Okay, so if there's no arrows, that means it is restricted. Okay, so number 1, it looks like the slope goes down 1 and over, a half. Okay, so let's go down 2 and over 1. That makes more sense. So y is equal to a -2x, and it certainly looks like the y-intercept is at -2. This is when x is less than 1. Oh, but we do have that restriction here too, which is 1, 2, 3, 4. Okay, so -4 less than or equal to x less than 1. Now, if you're asking yourself, why did she do less than 1? We don't actually know. That's a great question. The reason is because we don't know which piece has the open circle and which piece has the closed. What we know is there are two pieces connected at the same point. So definition of a function is that the x values cannot repeat, right? All of our domain elements have to be unique. So at this particular situation, ladies and gentlemen, please choose one. And when I say choose one is because this restriction is going to have to be greater than or equal to 1 since this one is not, okay? One of your pieces, if they connect at the same location and you cannot tell which one is opened or closed, one of them has to be opened, one of them has to be closed. One of them has to be equal to, one of them has to be not equal to. Again, if you need to write that down, write it down. Okay, so 1, 2, 3, 4, 5, 6. So then it is less than or equal to 6. If I'm looking, I go up 1, 2, and over 1, up 1, 2, over 1. So that means our slope is a positive 2x, but I'm going to have to extend down to figure out where my y-intercept is. And it looks like it's at a positive. Oh, no, it does not. Looks like it's at a negative 6 at this bad boy. All right, here we go. Final piece. F of x is equal to the equation negative 2x minus 2 when negative 4 is less than or equal to x, which is less than 1. It is equal to 2x minus 6 when 1 is less than or equal to x, which is less than or equal to 6. Now, if when you were doing this, you switched this to be equal to and this was not, that's fine. Again, you guys, you just need to account for the fact that 1 is equal to and 1 is not. All right. Hopefully that cleared up any confusion you might have had on the writing equations. If you have questions, I look forward to answering them when I see you.